Okay, so they want us to factor the expression, factoring out the greatest common factor. So looking at these three, you got to start by saying, what is a number? What number divides into 3, 21, and 3? Well, they're all divisible by 3, aren't they? 3 goes into all 3. So we'll put that in the front first off. And then for letters, right now we're finding out what they have in common, what the greatest common factor is. For letters, you take the lowest power for each. So when it comes to the x's, we're looking at x cubed, x to the fourth, x to the third. So the lowest one is going to be x to the third. And when it comes to y's, you got y to the third, y to the fourth, y squared. The lowest y is y squared. Okay, so that's the greatest amount they have in common. That goes in the front, and then we're going to put a big old parenthesis with 3 blanks. And then we're going to find out what would multiply to go back to these 3. That's the name of the game. So again, how did we get this 3x cubed y squared in the front? Well, it's the most they have in common. It's what they share in common, right? 3, all the numbers in the front, 3, 21, and 3 are all divisible by 3. That's the greatest number, the biggest number. It goes into all 3 of them. And then with the powers, you take the lowest power for x and the lowest power for y because that's what they have in common. Okay, now let's go step by step. This times what would go back to the first term. We basically just think out distribution backwards. That's what factoring is. It's unmultiplying. We just say, okay, what would work? 3x cubed y squared times what would go back to 3x to the 5th y cubed? Well, remember, out front numbers multiply, powers add. Out front numbers multiply, powers add. So this is going to be x squared y. How did I come up with that? Well, because 3, we already got the 3, and then x cubed and x squared goes back to x to the 5th powers add, right? And y squared and this one, now what about that? That really means y to the 1. You don't have to show the 1, but that's what it really means in order to go back to y cubed, right? Y squared and y to the 1 goes back to y cubed. Now, we don't show the 1. We put nothing on the y, but it's an invisible understood 1 because there's just one y, isn't there? But we do need that y. The invisible 1 adds to the 2 to go back to 3. All right. How about the next one? 3x cubed y squared times what would go back to this middle one? Well, out front numbers multiply. I need a 7. 3 times 7 is 21. And I've got x cubed, so I need regular x. I need y to the 4th, so y squared. Let's check it out. Well, how did I do that? 3 times 7 is 21. And then the powers add x cubed, and that's x to the 1, right? Plain old x really has x to the 1. Goes back to x to the 4th. And y squared goes back to y to the 4th. Out front numbers multiply, powers add. Final one, last one, let's do it. It's going to go all the way to here. So, and you got to make this term. So you need, no, wait, we don't need anything. It's got it all already, right? So you put a 1. You still need to multiply. You think, where'd the 1 come from? Well, because 3x cubed y squared times 1 is 3x cubed y squared, right? You would need a 1 there if you were distributing. If you were taking this 3x cubed y squared, you're going boom, boom, and boom. You can't leave a blank there. You can't put a 0 there, right? Anything times 0 would just be 0. It wouldn't go back to 3x cubed y squared, would it? So if you've got all you need a 1 here still, because 3x cubed y squared times 1 is 3x cubed y squared. You do need a 1 there. And so there we go.